let's summarize what we have said about Laplace transform, starting from the definition. So we have started with the definition that if we have f of t and we want to get the Laplace transform of this f of t, the result will be f capital of s, which is equal integration of integration limit first from 0 to infinity e to the power negative st times f of t dt. We started with the Laplace transform of 1, and we have proved that it is 1 over s. Then we have proved that the Laplace transform of e to the power negative at, a is any positive integer or number, f of t, it is equal to f of s plus a. So it is the same Laplace transform that you have derived for this f of t, just replace each s with s plus a. So from this rule we can prove that the Laplace transform of e to the power t equal, so we can use this this feature of Laplace transform, and knowing that the Laplace transform of 1 is 1 over s, so we can imagine that here there is a 1. Okay, so it is the same Laplace transform that we know, which is 1 over s, but we will replace each s by s plus a. In our case, a is equal minus 1. So you can imagine here is a minus 1. Minus is 1. So to put it in the same form of this formula. Okay, so here it will be s plus a, which is a is negative 1, so it will be s negative 1. So let's do it with our red color. S minus 1. Okay. So next we have proved that the Laplace transform of any derivative d f of t by dt, the nth derivative, it will be s to the power n times f of s minus some initial condition terms, s to the power minus 1 f of 0 minus s n to the power minus 2 f dash of 0, and so on, till s the derivative n minus 2 of f of 0 by the s n minus 2 minus the last term will be the derivative n minus. You can put here s to the power 0, okay, to be consistent of f of 0 ds minus 1. Okay, so the differentiation in time domain will be transformed into a multiplication in the S domain. Next, we have proved that the integration in the time domain is from 0 to t f of tau d tau. We have proved that it is f of s divided by s. Okay, so the differentiation is transformed into multiplication, and the integration is transformed into division. Okay, then we have proved that Laplace transform of t to the power n times any f of t that you know is Laplace transform. So it will be negative 1 to the power n, and the differentiation of this function, but with respect to s. Okay, here I have some mistake in this formula. This is t. This is the derivative with respect to t, and that one the derivative with respect to t. Let's erase it. Okay, so this is okay. This is the s derivative with respect to t, n minus 2. Again, so this is the t. Okay, but here this is the derivative with respect to s. Take care. Okay, then we have proved that proven that Laplace transform of t to the power n is, this is a very common rule, factorial n divided by s to the power s plus 1. And we have derived the Laplace transform of sine and cosine. Sine omega t is equal omega divided by s squared omega squared, and Laplace transform of cosine omega t equal omega squared, s divided by s squared plus omega squared. And we have also proven that the Laplace transform of any constant multiplied by a function, we can pull out the constant to be a f of s. And it's very simple to prove that the Laplace transform of f1 of t plus f2 of t will be equal f capital 1 of s plus f capital 2 of s. It's very simple from the definition, from the original definition of Laplace transform. Because the Laplace transform, as we said before, this is f of t. So if you have here f1 plus f2, this will be f1 plus f2. Okay, and this will be multiplied by them all. Okay, so you can divide this integration into two integrations. The first one will be integration of e to the power negative st f1 of t dt plus another integration e to the power negative st f2 of t dt. So this part is f1 of s, and this part is f2 of s. So the Laplace transform of them together in a summation form, f1 plus f2, it will be equal f1 plus f2, both are capital. Okay, so this is a very useful formula that will help us in our course. Thank you.